The objectives of this practice are to know and apply the preparation procedure for a metallographic analysis, to use a microscope to see different structures, to know how to prepare a sample for this type of analysis, and to use that type of analysis to identify the size of the grains of the sample.
This is abrasive disc cutter.
We are going to show you the parts of the abrasive disc. This is the lever, this is the disc, this is the press, this is the aluminum bar that we are using, and all the mechanical part of the machine.
First of all, we have to use a universal tube to open up the press and get out your aluminum bar so you can check the exact measure you need to cut. When you think you have the exact measure, then you use the lever to lower down the disc and see if it's exactly the same. If it's exact, then you use again your universal tube, close up the press, and then turn down your protective cape and turn on the machine with the green button. Okay. When it's turned on, you have to lower down your lever really slowly so you don't destroy the machine, because if you do it faster, you can break the cutter. Okay, when you finish, you only off your machine, turn down pressing the green button, and wait till the cutter is stopped totally. When it stops, you open up your cape and take out your piece of aluminum.
Hi. Now we are going to use the mounted press machine in order to make our piece better for analysis. First, you need to close it and pump here for the inside of the tube to come out. You need to clean it, then put Vaseline for it not to stick. And then our piece. You need to open it, the piece goes down, close it again, and add 1 scoop of bakelite. After that, you close it. Now you close it, and when you feel it hard, you turn it back 1/4 of a turn. Now we put the resistance and turn it on for it to heat up the inside of the tube, and pump it for 10 minutes at the red dot. That's about 99 megapascals. After that, we turn off the resistance, take it out, and put this piece in order to cool it down for 5 minutes, also maintaining the pressure. After 5 minutes, you open it, release the pressure inside, and open the tab. And here, we're supposed to have our piece.
After we take out our piece from the mounted press machine, we bring it to here to the sanding and polishing machine. In here, you have to put 2 types of sandpaper and sand it for 3 minutes with each. One paper is from 600 and the other one from 400. After you have sanded with the 2 types of sandpaper, you change it to the right side. In this side, we apply the alumina and we polish it for 3 minutes with the polishing paper.
After the sanding and polish machine, you have to attack the sample with the Keller. Then you have to drop some drops over the aluminum part, and then wait for 20 minutes to for the attack to be done. After the chemical attack, we open the Axovision program to start the microscope for a new analysis. We put the sample over here, then we move the axis here, adjust the brightness, and here adjust the focus. here we have the revolver with the different types of lens for the analysis, and after we have the best picture, we have the result over screen. After the optical microscope analysis, we got the results with 8 grains and 13 half grains. That makes a total of 6.5 grains. So in the ATESM grain size equation, at 100 resolution, we got that the number of grains size is 14.5, and in the ATESM grain size number we have 5. That represents a 65 microns average of diameter of the grain, which also represents a relative size of medium. That also represents that it's not very hard, ductile and consistent, but it's not that weak, and it can be used for many purposes.
Metallography is an important analysis method that we use to find out the mechanical, physical, and chemical properties on our metal or an alloy. It's important for industries because with that we can find out which material is the best for our manufacturing process. Well, the number that you can find in the sandpaper means the measure that have the grain of the sandpaper. With the measure of the sandpaper, you know how much will be the roughness that you will have in your material. The higher the number, the more smaller that will be the grain.
Over-attacking means that when you leave a chemical substance over your metal piece for a time greater than the one that is required, the piece becomes really dark and you can't see it in the microscope. So it's like if you burn it. So you have to polish it again and do all the process of attacking it to make it visible for the microscope.
Well, in conclusion, we got a successful result of the aluminum sample. We saw the grains, and I consider that it's really important the metallography analysis for industrial, because with that we can see how the material will be successful for the manufacturing process that we are going to have.
In conclusion, we are very happy for the results we have. We can interpret the result for the ATESM equation, and I'm also glad that I learned how to do this type of analysis because it's very important for us as professionals.
I learned a lot about metallography and how to apply it in the industry and how to make it useful in my future job.
Laboratory practice is to know the importance of the grains into a material because they are the ones that give them its properties. I found this really useful as an industrial designer because this will help me to choose a material not only for its appearance but also for the properties and the benefits that it will bring to my products.